A very good afternoon to all. This is Kumudi, Assistant Professor, Department of CSE, SNS College of Technology. In this video, we are going to discuss the Introduction to Algorithm Analysis under the Unit 5 of Data Structure subject. What is meant by algorithm? Algorithm is nothing but it is a step-by-step process to solve the computational problem. Okay. So basically this algorithm will be used to find the solutions for the complex problems. After providing a solutions, it will be go for an implementation part. Okay. These are part of the algorithm work. Okay. Basically, while we are going to the software development, we will have two important stages. 5 stages are there, but from that, the 2 stages are very, very important. The 2 stages, it will decide your algorithm and implementation part. Okay. The 2 stages are design and implementation. The first one is the design stage. The design stage, it will be used to design your user interfaces. This user front-end exchange for interfacing, we will use this design part. Implementation part, that already you know that it is a program. Okay. So before we are going into the algorithm analysis part, first you must familiarize on the what is the difference between algorithm and program. Okay. This algorithm, it will use our design stages in the software engineering, software development. Okay. While we are going with the program, it will use the implementation stage. Okay. If I have to write an algorithm for the complex problem, for that what knowledge I should have means, I should possess the domain knowledge to write an algorithm. For writing a program, we must have a programming knowledge. The programming knowledge like C, C++, Java or Python, any kind of programming knowledge we must acquire so that we can able to write a program to solve the computational problem. This algorithm, it can be written in any languages. Readability only we are doing this. So it could be done in any language. But while we are going with the program implementation part, we must return in programming language alone. So after completing your algorithm writing, we will go with the analysis to finalize your algorithm. Okay. But after implementation, we will go with the testing part, whether the implementation part is working or not, whether it is attaining this design stage or not. Okay. Then in the algorithm phase, they will use the priori analysis. That is, before we are going for the implementation, we will do the priori analysis. But while we are going with the program, we will go with the posterior testing. Okay. In this prior analysis, it is not dependent on language or hardware. Okay. But while we are going with the posterior programming stage, it will be a language dependent and the hardware dependent. While you are writing an algorithm, you must concentrate on time and space function. But posterior, whatever the thing which you have written in an algorithm, whether we are attaining or not, that will be just watched in a posterior stage. Here the space will be considered or watched in terms of bytes. How many bytes your algorithm is occupying to run your program. These are some of the characteristics we must have while we are writing an algorithm. We have to give an input, output. 0 or more input we have to give, at least 1 output we have to get, and definiteness. This will decide your quality of a predictable with great confidence. Then finiteness means certain limits. We should have a certain limits. Otherwise, your loop will go into an indefinite stage. The next one is effectiveness. Effectiveness means ability to produce the desired output. The next one is the how to write an algorithm. Normally before I have given two things. Okay? One is swap algorithm and another one is swap program. While we are writing an algorithm, we may not know the return type of our particular function which we are going to implement, because if I am having a domain knowledge, I can able to write an algorithm. But program only knows which data type I am going to use. Okay. Then we will start with begin. Then we will use the three variables to swap the values. Okay. Just here, the A value will be assigned to B, B value will be assigned to A. Okay. This will be written by the algorithm writer, and this will be written by the programmer. Okay. Here the algorithm it is replaced as a int, then A, B it is given as a integer data type, and here the A is assigned to 10 and B is assigned to A and 10 is assigned to B. Next, how to analyze the algorithm? The algorithm it will be analyzed in 5 bases: time complexity, space complexity, and network usage, power consumption, and CPU register. CPU register is nothing but the number of registers which you have used to store your data. The power consumption, after you are developing, how much power is consumed by your application. That thing should be taken care of here. And network, if you are running your application in the application through internet, okay, how much internet bandwidth you must have. Okay. Then this one is the next one is the time complexity and space complexity. How to calculate it? For that, just I have used the same swap program. While we are going to calculate the time complexity in your program, if there is any statement that will be executed within 1 millisecond. Okay, you can consider that it is executed in 1 millisecond. So 3 milliseconds it is execute your program. And space complexity, while we are going to space complexity, it will be calculated based on the number of variables which you have used in your program. Okay, here we have used the 3 variables A, B, and 10. So it is 3. For example, next example, you can consider x equal to 5 into A plus 6 into B. If while you are going to compute this kind of statements, it will check for the operator precedence. If the highest precedence operator is there, then first compute this. Then after next priority operator will be executed. Then it will be it will perform the operation based on the operator priority. In this example, first it will compute the 5 into A. Then second time it will compute 6 into B. Third time it will add these two values, and fourth execution it will be assigned to yes. So here the total number of function it is required. Time complexity is 4. F of n is 4. And the space complexity, again we have used the 3 operands x, a, b. So it is 3. This calculation, okay, this analysis, it is represented in terms of notations. For that, they are using the asymptotic notation. This asymptotic notations, it is used to describe the running time of an algorithm, and also it will compute the algorithm efficiency. For representing, there is in the 3 different notations: big O, omega, and theta. The big O, it represents the upper bound values. Omega, it represents the lower bound value. Theta, it will be represent both the upper bound and lower bound values. Okay. The big O means, upper bound means, I will calculate that my program it will be executed within the 4 seconds. Okay. If it takes more than 4 seconds, then it will be represented in big O. Then omega. If I am calculating same case 4 seconds, then my program execution it is done within the 3 seconds. Okay. Then we will represent the omega. Theta. Theta means if it maybe goes to up or down, depends upon the processor configuration or execution of your program, running time of your program, it will be represented. Okay, that is the theta. Here I have given as a graph, big O, f of x. Okay, the x is the number of function, the f of x is the main function, and g of x is the total time taken to run your program with constant value. If it is always high, then it is big O. Omega means the g of n, it will be always shown in the below of that f of n line. That is lower bound. This is the best case. This is worst case and this is average case. Theta, it will use the two constants, two different functions to with two different times. Okay. If it is my program, it is completed within this level lower bound. Okay. Then it will be represented with theta of g of n. Thank you. Thank you for watching.